Okay, welcome back. We're in the last part of 11.2, which will wrap up chapter 11. We're going to be talking about significance test for the mean when we're talking about a difference of paired data is what we're looking for. So notice the subscript there. So what we're going to say is that basically a lot of times the null hypothesis is going to be that difference is zero. So again, it's going to be from paired data from a random sample. And again, we still have our conditions there as we kind of take a look at that. Remember, for that normal large sample, if we're over 30, we're in the clear. If not, you better check the graphs to make sure that we don't show any signs of skewness or outliers. Okay, so what we'd have to do then is find the mean of the differences, subtracted zero, standard deviation. So you have to find the difference of them first, and then you can do your statistics on your mean standard deviations. And again, and the sample size should be the same for both groups because obviously you're finding paired data is what you're doing there. All right, so here we go. Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Now, each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. Now, during one 2-day period, subjects took capsules containing their normal coffee intake. During another 2-day period, they took a placebo. The order in which subjects took caffeine and placebo was randomized, and at the end of each 2-day period, a test for depression was given to all 11 subjects. Now, researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. Now, the table displays data on the subjects' depression test scores. Higher scores show more symptoms of depression. So we kind of see the data there as we see the paired group. So it's the same person. So subject one obviously had the caffeine for a couple days, did their score, and then of course the placebo. And you can see the differences there. So you might already have some evidence of what you're thinking about right now. You can probably see that. All right, so do the data provide convincing evidence at the 5% significance level that caffeine withdrawal increased depression score on average for subjects like one in the experiment? Well, so let's state, the mean difference is null hypothesis is going to be zero, and then our alternative hypothesis is that it's more. There is a difference, yeah. It's going to be bigger than that, so that the placebo minus the caffeine is going to be bigger than zero. We're going to see that there is a difference. And we did say that there was a significance level. Yeah, it says that it wasn't given, but it was. We're going to use 0.05. All right, so plan. We're going to do a paired t-test. Okay, paired this time for the mean difference. And so researchers, they said they randomly assigned them into those groups. Yeah, we do have our 10%. I'm sure that's 10% of all subjects. Yeah, and then if we look at our differences, if we look at that, if we plot that into a histogram, I think we're going to see very clearly that yeah, there's no outliers or skewness going on here. So we're okay. We check those. All right, the do part. Now again, I'd use the technology on this. If we took the differences here and found the mean and standard deviation, this is what you'd get. Okay, and again, the number, we had 11 of them here, so that was our sample size. So again, if you did the t-score this way with degrees of freedom, you could go to the table. But again, that table just gives you a kind of a in-between. I like using the technology. After you do that, you can certainly put that in there as your lower bound. If we're looking at what's above, so take it up to 1,000. That way, it's way above. And then again, our degrees of freedom are 10 because it's one less than our sample size. We get 0.0027. It looks like is what we have there. So I like that a little bit better. As we compare that p-value to our significance level, we are lower than that. So we are going to reject the null hypothesis. And so we do have convincing evidence for the alternative hypothesis that caffeine withdrawal does increase depression scores on average for subjects like ones that we see here. So that's our experiment there. All right, so now remember, you got to know the difference. Now, 2 sample T procedures require data that comes from independent random samples from 2 populations of interest, okay, or from 2 groups in the random experiment. Now, if we do the mean difference, we're going to pair them up, okay? It's paired data from a random sample or from a randomized experiment. So remember that the proper inference method depends on how we produce the data, so we got to make sure that we're doing that. So let's make sure we're able to identify this in each setting. Which one would it be? Would it be the paired data or would it be a two-sample T procedure? What would we use here? So let's look at A. Before exiting the water, scuba divers remove their fins. A maker of scuba equipment advertises a new style of fin that's supposed to be faster to remove. Now, a consumer advocacy group suspects that the time to remove the new fins may be no different than the time required to remove the old fins on average. Now, 20 experienced scuba divers are recruited to test the new fins. Each diver flips a coin to determine if they wear the new fin on the left or the old fin on the right foot, left foot, right foot, or vice versa. The time to remove each type of fin is recorded for every diver. All right, well, that's paired. Okay, that's paired because it's the diver doing it. It's their data that they have for old and new off each foot. So I think that's clearly paired. T. How about this one? To study the health of aquatic life, scientists gathered a random sample of 60 white piranha fish from a tributary of the Amazon River during 1 year. The average length of these fish was compared to a random sample of 82 white piranha from the same tributary a decade ago. I doubt very well. Again, your sample size are different anyway, so they can't be paired. They have to be the same. And I doubt you'd be able to catch the same fish again. So that's obviously going to be a two sample. They're from two independent random samples from 2 different years. So yeah, that one would be a two sample T. How about this one? Can a wetsuit deter shark attacks? A researcher has designed a new wetsuit with color variations that are suspected to deter shark attacks. To test this idea, she fills 2 identical drums with bait and covers one in the standard black neoprene wetsuit and the other in a new suit. Now, over a period of 1 week, she selects 16 2-hour time periods and randomly assigns 8 of them to the drum in the black wetsuit. The other 8 are assigned to the drum with the new suit. Now, during each time period, the appropriate drum is submerged in waters that sharks frequent, and the number of shark bites the drum is recorded. Again, I think in this case, we're going to be looking at a 2-sample T. We're coming from 2 groups, with each group consisting of 8 time periods with a drum. It's randomly assigned to be submerged. So yeah, it's not paired. It's not paired up, so it's 2-sample T. All right, so again, those are some examples of those. Make sure you know which ones we have, and this will wrap up Chapter 11. Again, some really good problems on page 739. Especially that 65 through 69 multiple choice ones. Those are always good ones to look at. We'll wrap those up, and then we'll start looking at the FRAPI and some multiple choice form assessments and prepare ourselves for the Chapter 11 test. After this, only one more chapter, Chapter 12 to go before we start reviewing for the AP test. So until next time, I'm Mr. Boone.